Hello and welcome to Normally Distributed, where we learn about probability and statistics with a sports twist. Today I am bringing you a video on random sampling. Today we'll talk about how to take samples as well as how to use those samples to make inferences. So first things first, let's go ahead and define the difference between a population and a sample. So a population is the entire pool from which a statistical sample can be drawn, or basically if your statistical question is what is the average amount of rebounds a player gets, their population would be all of the games that they've ever played. But a sample in this case, which is a subset of the population, which we use to make inferences on, would be a subset of the games. So let's say a player plays 352 games in their career. A sample would be taking a tenth of that, maybe 35 games, and trying to draw inferences on the entire population average just with those 35. So what is random sampling? So we've already discussed what a population is, as well as what a sample is. And then random sampling is just the process of selecting a subset from the population. And the key word here is random. If you want this sample to be a good representation of your entire population, then what it needs to be is it needs to come randomly. So if we go back to that original example with the basketball player who played 352 games in their career, and we want to find the average of those, the average amount of rebounds that they got in their career by taking a sample. We wouldn't just select games from the front half of their career or the back half of their career. We would want to select samples along their entire career. One way to visualize this is by drawing out the population. So let's say that the population is right here. This is the population of games that an NBA player has played in his career, 352 games. So in order to take a random sample, you wouldn't just cut this circle in half and just select this half here, because that's not random. Instead, what we would do is we would want to select random games. So we would say, take one from here, maybe one over here, and so on. We would just continue to take a random sample, figure out how many rebounds they got in each one of these games, take the average of that, and then we would be able to estimate their population average of rebounds per game. So now that we've defined random sampling, what can you do with it? And so one of the main things that we do with random samples is making inferences on the entire population based on that sample. Now an inference is saying something about a population. So in our case, what we're going to do here is we are going to use samples to say something about the mean or average of a population as well as the variance in a population. So as you can see, we have three different samples here, and each sample was taken from the NBA rosters, and I randomly took 10 individuals off all of the NBA rosters, and we have their heights listed here. For example, here in sample one, the first player we have here is 84 inches, or about 7 feet 2 inches, or sorry, that's actually 7 feet. Second sample here, we have 78 inches, which is 6 foot 6, and so on. So the first thing that we're going to do is we're going to look at the mean of this sample. And so the mean of this one, again, if you remember how to calculate the mean from our previous videos, you just add up all these numbers and divide them by how many you have. So we have 10 samples, so you add all of these up and divide them by 10. In this case, the mean comes out to be 78.2 inches. So we can say, based on this sample, that the population is most likely going to have an average of 78.2 inches, right? Let's take a look at this second sample and see if we get something exactly the same or not. So the mean for this one is going to be 76.6. So what happened here? Why is there almost a 2-inch discrepancy between the two samples? Again, we're just taking samples. When you have an NBA that has 300 plus players and we're only looking at 10 of them, we can't get the same exact mean every single time. What you'll see when you're taking samples, though, is that the larger your sample, the more close it is going to be to the actual population value. So if we took a sample of, say, 200 out of 300, the average of those 200 players is going to be a lot closer to the average of the entire population, as opposed to these samples, which are only 10 players. So if we continue this all along the line, we have the mean of this last group is equal to 76.1. And again, it's not exactly the same, but these two samples are actually relatively close. And then another thing that you're going to want to look at is a measure of variability or measure of spread. In our case, we're going to look at MAD, mean absolute deviation. And again, if you want to calculate the mean absolute deviation, you take these numbers here, so 84 minus 78.2, find the absolute value of that, and then find the average of all 10 instances of this. So in this case, we calculate out the mean absolute deviation as 3.4. This MAD is going to be 3.6, and this MAD is going to be 3.7. And what's really interesting here is that our mean absolute deviation doesn't change too much. So that could mean that this is a really good representative sample, which is usually what happens when they are completely random. Thank you for watching. This has been Random Sampling brought to you by Normally Distributed. For some more learning resources and practice problems, please visit our website. If you liked this video, comment, like, or subscribe. Thank you, and until next time.